There's this whole other world right under the top of the mussels. They really are like forests underwater. They serve as key structuring species. They provide habitat for many other species of algae. They provide living space for lots of small organisms that in turn serve as a food source for other fish species, crab species. And so what happens to the mussel beds drives a lot of the ecology of underwater habitats. So once that's gone, it's like clear cutting a forest. There's just no habitat for those animals to live anymore. Some mussels are doing fine under climate change. Other species are not doing so well, and we're seeing them disappear. We're seeing declines in mussels in many parts of the world, especially here in the Gulf of Maine. We suspect that a lot of it has to do with climate change. When we see these heat waves that are associated with climate change, we can go out in the rocks and we can see mass mortality. We can see mussels just baking in their shells, sitting in the rocks with all the tissue still in place. You go back a couple days later and all the shells are gone and the mussel bed is completely wiped out. One of the challenges of communicating climate change is that, understandably, we see the world as humans, but 99% of organisms on Earth have a completely different way of experiencing their environment. Their body temperatures are driven by the external environment. And so in the case of many mussels, that means that at low tide, when they're exposed to the air, their body temperature is being driven by the sun. To understand impacts of climate change on non-human plants and animals, you kind of have to take a step back and view the world as that non-human organism. So that's what we try to do with these robomussels. I came up with this idea of creating these biomimics once commercial sensors small enough and rugged enough to be put out in the environment became available. They absorb heat the same way that the animal does, and then we have a little tiny computer on the inside that records that temperature. If you look at the world through the eyes, if you will, of a non-human animal, you see patterns that are otherwise completely invisible to us as humans. So places that we think are benign, the animals may be baking off the shore just because they're experiencing their environment in a totally different way.
It looks like cat throw.
Is that old? This stuff? No, this is the one I just made. But like these are where my loggers were.
By putting these out in mussel beds, it tells us how close to death a lot of these animals are. From site to site, there are huge differences in vulnerability of populations just because of the very local conditions. Part of what we try to do is forecast what sites are best to save some of these animals. We look at these site level effects, where if we can identify locations where mussel beds are still doing pretty well, it's a pretty good indication that those are sites that should be preserved, that should be prioritized. If you're able to preserve mussel beds, those in turn serve as a refugia for other species of organism that can repopulate the surrounding environment. And we have identified some of those in places like Northern California. Finding ways of not only communicating climate change impacts, but developing tools that help us to prepare for the worst of those impacts. And not just mussel beds, but in general, figuring out ways that we can preserve a lot of the ecosystems and the services that they provide to society becomes very personal to me. It's hard not to get depressed when you think about the environment that's likely to be here in 20 years even. The environment that my daughters are going to see. I mean, I really deliberately try to take them out into the field with me to see some of these sites because they may be gone even the next 5 or 10 years. So I feel like anything that I can contribute to the broader scientific discussion about how we conserve these environments ultimately is going to benefit my kids.